Hello folks, and welcome to yet another calculator video, although this one is slightly different. Last time we looked at the Faucet 1126, a significantly more modern machine, although it has all the features of this one. This right here is a Cellatron. It has quite a nice logo on it, I think. It was designed in the DDR, or the Deutsche Demokratische Republik. I probably mangled the pronunciation of that, but the German Democratic Republic before the wall fell. This was one of the last mechanical calculators designed in the DDR, I've come to learn. And the manual is in German, so I have had to sit around and translate it. Fun stuff. That being said, let's uncover the thing. And here we have it. Big console of about 20 keys. Has some settings already in it. Can be cleared with a button like this. Have a button 1 to clear the counter register and all of that jazz, but we will get to it. It works much like a comptometer in that you set numbers by depressing the individual columns. So 256 would be done by pressing the 3, the 2, the 5 and the 6. Then the machine does what you would expect a machine of this kind to do. Does addition, does repeated additions even. And this is done because of this lever here, the repetition lever. Let me see if you can see it. There we go. You see the little R there. And if I flick this down, you can watch what happens to these keys when I hit the addition button. Actually, let's mix things up. Let's hit subtract. And you can see that they pop up again. That being said, we can do all sorts of things. We can add several different numbers, just like so. And as we can see, they then appear in here, the result and the counter register. The result register is where numbers go when tallied. The counter register, much like on the older style calculators, keeps a lookout for how many items you have added or subtracted. If you add some stuff, you'll see both of them incrementing, one by one and one by the number we're adding. This one also features a rather interesting aspect of subtraction, because as you will see, most of these calculators actually do not cope with negative numbers particularly well. So if I press the subtract key now with a number that's significantly larger than the one we have in the result register, you'll see, boom, I have a row of 9s, and we have our complement number here. Normally this would be cause for some sort of corrective calculation, but not on the Cellatron. No, then you just take this lever here, you flip it down, and you see the complement register displaying the negative number in a more positive light, so to speak. But we will return to our hideous complement number, and we can continue on to some more fun forms of arithmetic, such as multiplication and division. So for starters, we clear keyboard, we clear clear the result register, and we clear the counter register. That in mind, in order to do multiplication, there are some steps that are required to be followed. For instance, there's a fast multiplication, which is done just by setting the number in the 2/2 of the keyboard. You may have seen there's a darker row here. I will see if you can see it on the camera. On the small screen it's not very clear, but this line of keys is actually red. This signifies the 2/2 of the keyboard, and this is a rather revolutionary technique employed by the Euclid, Mercedes and Cellatron series. So, to do multiplication, all I need to do is to set a number here, such as 125, and then I set the other factor here. So say 125 times 58, let's say. With that done, we press the multiplication key and presto. And there we go, we have our multiplication getting carried out. We can see the original, or one of the factors, the multiplicand, in the right half of the keyboard. And in the result register, we see the amount we multiplied with, see 58, and we see the result. In our case, it looks like 7,250. Very neat. Then I can also take this opportunity to show you the memory feature of the calculator. It's not something that you would commonly find on most mechanical calculators, but this one does take the cake. If you press the S key, it will be the number in the result register will be appended to the storage register up here. Boom. And the result register will be cleared, just like that. Now, this can also be used for totalizing. So if I clear the keyboard and I put in 250 and I add that, and then I press the S key again, you will see that 250 will be added to what we have here, for a total of 7,500. Now, if I wish to make use of this somehow, I can return it to the result register with a push of the SL button, like so. And you see, up, down. Very neat feature. On that note, let's see, what else do we have? Oh yes, we have some interesting features, because since this machine has such a very large keyboard, we can actually use the entirety of it in order to perform multiplications. Let's say someone is earning a fair bit of income. Let's say I'm Swedish, so I will go in SEK. Let's say they earn 41,780 SEK per month with a 2 decimal component. I can input this here. Then say I wish to figure out the income tax for it. I can do this using the lever to the left here. You'll see it as it's the 1 through 10 or 1 through 20 lever. I'm going to flip this and then start a multiplication. So I flip this lever, it goes click, and now I'm going to push this button. It's going to move this number into the multiplier register and shift the carriage. Then I'm going to input the tax amounts, in our case 29% income tax for a 71% remainder. You see that the engine is now idling, waiting for our input. So 29% to 71%. And we execute the multiplication by releasing this lever, and watch what happens. Clack. And so we can see that we have our numbers. We have on the 11th row it starts, but there's 2 decimals. Actually there's 4 decimals, come to think of it, because in each of the products or factors we have 2 decimals, and in multiplication the number of decimals in the final result is always the sum of the components. In this case we can see that our fictional rich person is earning, they're paying 12,116 SEK and 20 öre in income tax. The remainder after the state has had their share is 29,663.80 SEK. And we see the original number we input here, which was 41,780. So that's how multiplication works, both with large products and with well, double factors as well. On that note, we have a few things more to show. We have, for instance, we have division, which I'm sure some of you might be interested to know how much this amount here is in dollars, and I'm only too happy to oblige. So I'm going to input 29,663 into the keyboard, and I'm going to divide this by the amount in dollars, which I believe last time I checked was 8.47. Now, the comma rule is a little bit particular and I'm not entirely in on it yet. So it's 63.80 then. So this becomes then a 5-digit number. Yes, a 5-digit number plus 1, so 6. And this is a 1-digit number, so 5. No, I'm not entirely sure I'm doing this right yet, but it's a work in progress. We will see where it takes us. Let's clear these registers and launch the division. And I will just zoom in a little bit so that you can see more clearly what it's doing. You may have seen this machine do this before, but it's always worth seeing again, I feel. So let's begin. Boom, done. So we can see that the original amount we input, 29,000 something divided by 8, is about... That's nice. I was actually right before when I said it was 5 decimal places. So it's $3,502.12. That's interesting, I feel. On that note, we can look some at chain multiplication. Those of you who have followed my channel and seen my previous things knows that one of the things I like to calculate in order to test a machine like this is the number of minutes or seconds in a year, depending. So I'm going to clear the keyboard, and I am going to show you the chain multiplication feature, which is done using this, the M key, which puts whatever is this section of the result register into memory for future multiplication. It's all a bit academic, but rest assured I will show you. I flip this switch here, which controls the coupling between the multiplier key and these keys. So now if I push this, or this key, it will also perform a multiplication after the operation is completed. This way I only have to push one button to do what I wish to do right now, rather than two. Also, because this lever is set in the 1 position here, any presses of this button is going to clear the counter register, which is going to be useful for us. On that note, let's get the number of seconds in an hour. So for starters, I shift the decimals over just to make it a little bit more readable. And I add this. Then I add another one to multiply this by 60. 60 seconds and 60 minutes. And by pushing the M key, the number 60 is transferred into the multiplier register. It's multiplied by what I had in the keyboard, in this case 60. 60 times 60 is 3600. Let's see if you can see that. Yes, I believe I probably can. Yes, so we continue. Next, we want to find out how many seconds are there in 24 hours. So I just put 24 in the keyboard and I press the M key again. And there we go. 3600 times 24, which is what I have in the keyboard, is 86,400. So that's the amount of seconds in a day. Next up, we want to find how many years we have. So 365 times what is in here, that is to say M key to the rescue again. Clack, and we are finished. This is then, just for fun, I will move it into the savings register, or the storage. Whoops. And because I had this multiplication lever, because this was checked, it tried to do another multiplication, even though the value of it was 0. So here we have it, the number of seconds in a year. 31,536,000. Very neat. On that note, I think I've shown you a majority of the features. I will just, because I know I said earlier that I would create sort of an overview of the machine functions. We also have two levers we have neglected to mention. We have the negative multiplication lever here, which I am going to need to move the camera something fierce for you to see the little signage on. Actually, I'm starting to think that moving the stand for the camera was a poor idea, and what I should instead have done was to gently disconnect the camera and take you on a small flight over here. And there we go. This switches the direction of the multiplier. So if I push this down, the multiplication is going to be negative. Push it up, it's positive. Then we have here, we have the division precision lever. This one means process the division to 10 digits of accuracy. process to 6 digits of accuracy, and process to 4 digits of accuracy. And I'm going to demonstrate to you the difference between the three of them now. There we go. Camera is a little bit jostled about having been moved, but it's something it will have to deal with. So, in order to demonstrate this to you, I will first clear everything. Then we are going to set up a division for pi, which is 355 through 113. Now I will press the division key and you will see how it processes the four digits of accuracy. And there we go. It's satisfied with a day's hard labor, as it were. But of course, this is insufficient for our purposes. So we clear everything again, and we do 355 through 113 at 6 digits of precision. And I'm fairly sure you can guess what result we are going to get here. So let's go. I would try to talk over the machine, but let's face it, it's a losing battle. And here we go, 6 digits of precision, so 3.14159. But of course, we have the R44 SM. There is no reason for us to settle for anything less than the full 10 digits, so that the people who cheaped out and got the R43 SM with only 16 digits or 8 digits in the counter register feel like they got their money's worth. We can't have that. So, once again, pi to a 10-digit precision. Let's go. Wonderful. Now, finally, I have one last thing to demonstrate, just for the sake of completeness. And that is this unlabeled button here. This is the counter reverse button. If I clear the counter register and demonstrate with a bunch of repeat additions, you will see what I mean. There we go. And I flick the repeat switch so I don't have to input anything else. I just give it a 1, 2, 3. Now, watch the top register here. And you'll see 1, 2, 3, 4. And if I subtract, 2, 1. But if I depress the counter reverse thing and I press plus, it'll add, but at the same time the counter will decrement. Meanwhile, if I subtract, the counter will increment. If I bring it back to its normal position, but it won't actually change anything because I haven't exactly figured out why yet. It takes a couple of revolutions. I'm sure there's a valid reason for it, but if there is, I have absolutely no clue. On that note, I would like to thank you very much for watching. If you managed to stay through the entire thing, I hope you've enjoyed it as much as I have. I'm very happy to have this machine. It's an absolute marvel of old technology. But with that in mind, thank you very much for watching, and do take care.